Welcome again. Once again, welcome to the engineering chemistry course. Before starting, just revise what we have learned in the previous class. In the previous class, we have started with the basic rules for the combustion based numericals, in which we have discussed that in the combustion based numericals, first of all, we have to calculate the amount of oxygen required for combustion, then amount of air required for combustion of a fuel. Then we have also learned that how to convert the weight of air or oxygen to the volume. And we have also discussed to calculate the percentage composition of the dry products of the combustion. Just have a quick recap of the various rules which we have discussed in our previous class for solving the combustion based numericals. First of all, write the balanced combustion reaction for all the combustible constituents present in the fuel. What are the combustible constituents here? The combustible constituents in the fuel are carbon, hydrogen and the sulfur. Nitrogen and ash are not considered as the combustible substances. Third, the net amount of oxygen required for combustion is equal to the theoretical oxygen required minus oxygen present in the fuel. So, if there is oxygen also present in the fuel, then we must subtract the amount of oxygen present in the fuel from the theoretical oxygen required, which we have calculated, to get the net amount of oxygen required for combustion. Fourth rule, we have learned that first to convert the percentage of constituents into the amount. For example, if a fuel sample containing 80% of carbon, that means we have to convert it into grams or kilograms. So we can write it as 0.8 kilogram or 800 grams. Next, we have discussed that the amount of air required for combustion is calculated by the amount of oxygen required for combustion. How we calculate it? We have to multiply the amount of oxygen required by the figure 100 divided by 23. So, total amount of air required for combustion is equal to 100 by 23 multiplied by amount of oxygen required for combustion. So this is the amount of air required for combustion. Next, we have learned about the volume of gas, conversion of the weight to volume. For this, we have learned that the given amount of gas may be converted into its volume by multiplying the amount of gas by 22.4 divided by its molecular weight. So, any amount of gas can be converted into its volume by multiplying it by 22.4 divided by its molecular weight. Then we have learned to calculate the amount of dry products percentage. So, in the last class, we have learned that the dry product of combustion are carbon dioxide, sulfur dioxide and nitrogen. This nitrogen is released in the dry products by air, which is supplied by the air, or which is also some amount of nitrogen may also be present in the fuel. So basically, nitrogen which releases as a dry product of combustion is supplied by the air, plus some amount of nitrogen is also present in the fuel. So the total weight of nitrogen is the sum of the nitrogen supplied by air and the nitrogen present in the fuel. So these are the dry products of combustion. To calculate the percentage of the dry products, we have these formulas. Percentage of carbon dioxide is equal to amount of carbon dioxide divided by total weight of dry products multiplied by 100. Percentage of sulfur dioxide is equal to amount of sulfur dioxide in dry products divided by total weight of dry product multiplied by 100. percentage of nitrogen is equal to amount of nitrogen divided by total weight of dry product into 100. That's all we have learned in our previous class. So in today's class, let us continue with the basic rules for the combustion based numericals. In the today's class, we are continuing these basic rules and will be discussing the amount of air required for combustion if excess air is supplied. So how we calculate the amount of air required if there is the excess supply of air. Secondly, if excess air is supplied, then how to calculate the amount of dry product. These two things will be discussed in the today's class. So remember, in the today's class we are going to discuss the fact that when excess air is supplied in combustion, then total amount of air required, how we calculate the total amount of air required, and how the dry products of combustion will be calculated. So suppose, let us take the example which we have discussed in our previous class. This is the same numerical which we have discussed in the previous class, but the difference is that in this now we have to calculate the air required for combustion and the dry product if 40% excess air is supplied. Numerical is the same which we have learned, which we have discussed in our previous class, that the coal sample containing carbon 75%, hydrogen 8%, oxygen 2%, sulfur 3%, remaining is the ash. Then calculate amount of oxygen and air required if 40% excess air is supplied, and calculate percentage composition of dry products if 40% excess air is supplied. So how will we calculate these amount? To calculate the amount, in the last class we have discussed that the amount of oxygen required is calculated by this way, that first we have to write the balanced equation, and then from this balanced equation we can calculate amount of oxygen required for combustion of carbon, for combustion of hydrogen, and for combustion of sulfur. So just we have to take sum of these three to calculate the amount of oxygen required for combustion. So what we have done here, 2000 plus 640 plus 30, and we have to subtract the amount of oxygen already present in the fuel. So the net oxygen required for combustion is the 2650. This we have already discussed in our previous class. And the amount of air required is the amount of oxygen required multiplied by 100 by 23. So this is the amount of air required for the combustion reaction. Now the case is that if 40% excess air is supplied. So what is the 40% excess air? 40% excess air means 40% of the minimum amount of air required. So this is the minimum amount of air required, and its 40% excess air is supplied. So this is the minimum amount and its 40% is the excess amount. So what the total amount, what will be the total amount? Total amount will be the minimum amount of air required plus its 40%. This will be the total amount of the air supplied. So the total amount of air supplied is the minimum amount, this, and the 40% of this minimum amount. So to calculate the 40% of this minimum amount, we have to multiply the minimum amount of air required by 40 by 100. If it will be suppose it is 50%, then we have to multiply it by the 50 by 100. If it is 45%, then we have to multiply it by 45 by 100. So whatever is the amount, we have to multiply it by the minimum amount of air required. So the total amount of air supplied is the minimum amount of air supplied plus the excess amount. What is the excess amount? whatever percentage given in the numerical, we have to multiply this percentage to the minimum amount of air supplied. So this is the excess amount of air supplied. Now add this excess amount to the minimum amount to get the total amount of air supplied for the combustion. So now I hope it is clear that total amount of air supply is the minimum amount of air required for combustion. This is the minimum amount plus excess amount, whatever percentage it may be. Right? So this is the total amount of air if 40% excess air is supplied. I hope it is clear to all of you now. Now, second case is the calculation of the dry products of combustion if excess air is supplied. Now, in this case, what are the dry products? We know, as we have discussed, that the dry products are the carbon dioxide, sulfur dioxide and the nitrogen. This nitrogen comes from the two sources. One is supplied from air, second is present in the fuel itself. Now, in case if excess air is supplied, then the oxygen present in this excess air is also included as the dry product. Why? Because the oxygen required for combustion is supplied by the minimum amount of air. Whatever amount of oxygen present in the excess air must be released as a dry product. So, if excess air is supplied in the combustion numericals, then the dry products will be carbon dioxide, sulfur dioxide, nitrogen and oxygen, which is present in the excess air. So there is the difference. If excess air is supplied, oxygen in excess air must be included in the dry product. But if excess air is not supplied, then oxygen is not be included in the dry product of combustion. So it is clear to all of you now that oxygen is considered in the dry product in the only case when excess air is supplied. Now, if let us take this example again. In this example, look at here, for the calculation of the carbon dioxide as a dry product, we know we have to multiply the amount of carbon by 44 by 12. So this is the amount of carbon dioxide. H2O is not considered as a dry product, so we are not considering H2O here. Sulfur dioxide calculation, we know that 64 gram sulfur dioxide is produced by the 32 gram of sulfur. So to calculate the amount of sulfur dioxide, we have to multiply the amount of sulfur by 64 by 32. So this comes the 60 grams. So the carbon dioxide released is the 2750 gram, while the sulfur dioxide release is the 60 gram. Clear? Now, two dry products we are calculating here. Carbon dioxide, already we have calculated 2750. Sulfur dioxide, we have calculated 60 gram. Now, what about the nitrogen and the oxygen present in the air? Now, to calculate the amount of nitrogen in the air, we have to multiply the total air supplied by 77 by 100. And what is this total air supplied? This total air supplied is the minimum amount of air plus the excess air. That means this amount which we have just now calculated. That means total air in which excess air also included. This 40% is also included. That is the total air supplied. So to calculate the amount of nitrogen in a dry product, we have to multiply the amount of total air supplied. This is the total air supplied amount multiplied by 77 by 100. So this gives the amount of nitrogen in the dry products. This is the amount of nitrogen in the dry product. So we have here the amount of carbon dioxide, amount of sulfur dioxide and now amount of nitrogen. Next is the amount of carbon dioxide in the dry product. You must remember the amount of oxygen is considered in the dry product only when if the excess air is supplied. So we have to calculate the amount of oxygen in the excess air only. Clear? So excess air amount is the 4608. How this amount comes? The excess air is only the 40% amount. This amount is the excess air. So this amount is the excess air amount, which is the 4608.696. This 40% amount is the only excess air amount. So this is the 4608.969. This is the excess air. So we have to calculate the oxygen in this excess air only. So amount of excess air multiplied by 23 by 100. Why we multiplied it by 23 by 100? Because we know that by weight in the 100 parts of air, oxygen is only the 23 parts. Therefore, we multiplied it by 23 by 100. So this is the 1060 gram. This is the amount of oxygen in the excess air only. So now it is clear. Amount of CO2 2750, amount of sulfur dioxide 60 gram, amount of nitrogen which will be calculated in the total air supplied, which included the excess air also, while amount of oxygen is calculated only from the excess air supplied. So these are the total amounts of the various dry products. Now the total of these dry product will be the amount of carbon dioxide, amount of sulfur dioxide, amount of nitrogen and amount of oxygen. So this is the amount of total dry products, total weight of the dry product. Now different percentage of the different dry products will be calculated with these formulas. Amount of carbon dioxide is equal to percentage of carbon dioxide is equal to amount of carbon dioxide divided by total weight multiplied by 100. So this comes to 16.88%. Percentage of sulfur dioxide is equal to amount of sulfur dioxide, that is 60, divided by total weight of dry product. This is the total weight multiplied by 100. So this comes to the 0.3683%. Amount of nitrogen will be the percentage of nitrogen will be the amount of nitrogen divided by total weight of dry product multiplied by 100. So this, with this formula we have calculated the percentage of nitrogen 76.24%. Then percentage of oxygen is equal to amount of oxygen in dry product divided by total weight of dry product into 100. This comes to the 6.5%. So these are the percentage of various dry products in case excess air is supplied. So I hope the concept of the excess air supply is now clear to all of you. So time for your learning check. Just read the numerical and solve this numerical in detail, and we will be discussing this numerical in our next live class. So the numerical is a sample of coal was found carbon 75%, hydrogen 5.2%, oxygen 12.1%, nitrogen 3.2% and ash 5%. Calculate minimum amount of oxygen and air required for combustion and weight of air required if 40% excess air is supplied, and also calculate the percentage composition of the dry products. So please please solve this numerical in your copy, and in next live class we will discuss this numerical. Now revision time. What we have learned in today's lecture: in today's class we have learned the concept of the excess air supply. In case if excess air is supplied for combustion, how we calculate the amount of air required for combustion, and how we calculate the percentage composition of dry product if excess air is supplied. We have learned that if excess air is supplied, then the total amount of air supply is equal to air required for combustion. This is the minimum amount of air required for combustion plus excess air supplied, whatever percentage, 40%, 50%, 30%, whatever it may be. So addition of these two will be the total air supplied for combustion. And the dry product of combustion in case of the excess air supply will be carbon dioxide, sulfur dioxide, nitrogen and the oxygen. Nitrogen from total air and also from the fuel, and oxygen is only from the excess air. This what we have learned in the today's class. Please read carefully, watch the video carefully and solve the numerical. Okay. Thank you. Take good care of yourself and keep enjoy e-learning at home. Thank you.